Okay, hey girls. So today we are going to look at a new type of expression or function called rational expressions. And a rational expression is the ratio of two polynomials. So we had so much fun with last chapter's polynomials. We're going to double the fun this unit. So we can say, like, if R of X is our rational expression, it is made up of a polynomial in the numerator and a polynomial in the denominator. Okay, and you'll see more what that looks like when we go to examples. And then this little expression here just means that Q of X cannot equal 0. And if you notice, Q of X is what they call the polynomial in the denominator. So this just means no matter what kind of expression you have, you want to make sure that that the value of the denominator would not be 0, because again, when you think about it, like 3 over 0 is undefined, right? So you can never have 0 in the denominator of a fraction. So when we're talking about expressions that have variables, we want to make sure that there's no value of the variable that would make the denominator 0. So we'll talk about that later as we go through these. So, a rational expression is in its simplest form whenever its numerator and denominator are both polynomials that have no common divisors. So another word for divisors is common factors. So a big part of this unit is factoring and making sure we cancel out common factors. Okay, so let's see what we got. So first we're going to just simplify rational expressions. And the first thing we're going to do is factor. We are going to factor numerator and denominator in any of the ways that we know how, such as GCF, AC method if we need it. We don't need that too often. Reverse FOIL. What else do we have? Difference of squares. And what's another one? See, GCF, AC method, reverse FOIL, difference of squares, and guess and check. Okay, but really any type of factoring is fair game. Then we're going to cancel matching factors from top and bottom. And we want to be sure we don't break up what I call factor families. And by a factor family, I mean when we factor and we get like a binomial, like x plus 4 or like x minus 7, you always want to be careful to put those in parentheses. And you can't cancel just parts of those. You can only cancel the entire factor if they're matching. Okay, so let's see what we got. So let's look at example 1. And first, let's try to simplify the numerator. So this we can simplify by taking out a 2x, and we're left with x minus 3. So I just took out a GCF of 2x, and I've got x minus 3. My denominator, it's about as simple as it can get. So now I have factored it. Now I want to cancel out matching factors. The 2x's cancel out, and my answer is x minus 3. So I have simplified that rational expression starting with this. Now it is x minus 3. Okay, let's try another one. Number 2. Again, the numerator is fine, x minus 3, but I'm going to put in parentheses because it is a factor family or its own expression. I look down the denominator, x squared minus 9. I can factor by x minus 3. X plus 3 is the difference of squares. I have matching factor families right here and right there. So I can cancel out those x minus 3s. And I am left with nothing in the numerator, so I'm going to put a 1. And in my denominator, I have an x plus 3. Okay, so that's my simplified rational expression. Now, again, I want to think back to this notation that Q of x, or whatever is in the denominator, cannot equal 0, because that would make the denominator 0, which would be an invalid value. So when you finish simplifying, if you have a variable in the denominator, you want to just write the expression that x cannot be equal to whatever value would make that 0. In this case, it would be x cannot equal -3. Okay? I'll talk more about that when we're in class. There's some confusion about those expressions. Okay? Now let's look at the third one. So here, yes, the third one. So I'm just going with my pen. So let's factor the top. So to factor this, I want to think what multiplies to -6 adds to 1. So I'm going to say x plus 3 and x minus 2. Right? That will multiply -6 and add to +1. Down here, I want to think what multiplies to -10 adds to +3. And that would be x plus 5, x minus 2. So now I have factored numerator and denominator. I see what can cancel. X minus 2's can cancel. So my final answer is x plus 3 over x plus 5. Now I want to think about what values could make that denominator 0, because we don't want to allow those. We're actually stating the official word for what I'm about to do is stating the domain restrictions. So we're saying what values should, if this were a function, what values should x never be, or should never be. And here we would never want x to be a -5, because that would make the denominator 0. So there's my final answer with the domain restriction. Okay. Now let's try another one. So we come down here to number 4. We factor the denominator. So what multiplies to 6 adds to -5, and that would be x minus 2 and x minus 3. And now when I look at this, it's a difference of squares. It's written a little bit different than we're used to, but it's still a difference of squares, and I could factor it as 2 minus x, 2 plus x. Okay, hopefully you guys see that. However, on this subtraction, so this, on this subtraction, I really would like it to match x minus 2, right? But this one does not match. In fact, it's exact opposite, because the 2 is positive here, but negative here. X is negative here, but positive there. So here's just a little trick we can do to be able to cancel. If I took out a -1 from this expression, it would change the sign of the 2, right? It would make the 2 negative, and it would make the x positive. So then I could cancel those out. So now I'm going to factor the bottom, but I'm going to, instead of just 2 minus x, 2 plus x, I'm going to say -1, x minus 2, 2 plus x. Now I can cancel the x minus 2's, and I'm left with x minus 3 over -1, 2 plus x. Now, since that -1, I could keep it on the bottom, but anytime one piece of a fraction is negative, it really makes the whole fraction negative. So I really could just write it out like this. And then my domain restriction would just be that x cannot equal -2. Okay. All right, let's try another one. So number 5 here. That's strange. So now again, we want to factor, and again, don't forget GCF factoring. That's really one of the easiest, but people tend to forget. So we look at the numerator. I can take out a 5 and an x, and I'm left with x minus 3. Denominator, I can take a 3x squared out, and I'm left with x minus 3. So let's just make sure that, yep. So now my x minus 3's can cancel. And then when I look at this, I've got 5x over 3x squared. So actually I have 1x on the top, 2 on the bottom. So this one can actually cancel with one of those. My final answer is 5 over 3x. And my restriction would be x cannot equal 0, right? Because if I set 3x equals 0, x cannot equal 0. Okay. Okay, so that is simplifying. Next, I want to move on to multiplying. Multiplying is very similar. We're still going to factor, and we're going to cancel. But here we can cancel any factor on the top with any factor on the bottom. So I want you to think about when we multiply fractions. If I multiplied like 2 times 7 times, let's say 3 over 10, right? I could multiply those across right away and get 6 over 70, right? And then I could simplify that. I could take out a 2, and I'd get 3 over 35. Or right here, before I multiply, I could think, well, 2 goes into 5. 2 goes into 10 5 times. So I could simplify it first, then multiply, and I would get 3 over 35. So I could either multiply first and then simplify first and then multiply. The same holds true for multiplying rational expressions, although it's easier and you really want to and you need to simplify first, okay? But you could always simplify later again if you forgot something. So let's try one of these. So right here on number 1, I want to first factor everything I can. So I factor the denominator here. What multiplies to negative 12 adds to 1. It's going to give me plus 4 and negative 3. I can factor the bottom. X squared minus 9 is x minus 3, x plus 3. I can factor 2x plus 6. I can take out a 2, and I get x plus 3. And then I can't do anything with x minus 5. So now I have factored everything. And now I can cancel anything in the numerators of either one with anything in the denominators of either one. So in this case, my x minus 3's can cancel. My x plus 3's can cancel. And now I just look on the whole denominator or numerator and see what I have left. And I have a 2 and an x plus 4. I look at what I have left in the denominator, and I have x minus 5. And that's my answer. My restriction is, again, I want to restrict anything that would make the denominator 0. So we would say x cannot equal 5. Okay. Let's try another one here. So if I look at this one, I want to factor the top. What multiplies to negative 10 adds to 3, x plus 5, x minus 2. What multiplies to 14 adds to negative 9, x minus 7, x minus 2. Can't do anything with this 5. X squared minus 25, I get x minus 5, x plus 5. Now, anything on the top can cancel with anything on the bottom, so I can cancel my x plus 5s, cancel my x minus 2s, and I'm left with 5 over x minus 7, x minus 5. And so that's my final answer. My restrictions would be that I don't want x. X cannot equal 7 or 5. Okay. Now let's just do one more. Come down next, number 3. I'm going to, again, first I'm going to simplify everything. So I'm going to take out this 2, and I get x minus 4. I take out x squared minus 16 is x minus 4, x plus 4. I look over here, I get factor x squared plus 5x plus 4, I get x plus 4, x plus 1, and x plus 4, x plus 4. This last thing. So you really do want to make sure you're up on your factoring, and we'll practice this some next class also. So now I can simplify anything on the top with anything on the bottom. So my x minus 4s can cancel. Only one x plus 4 in the denominator can cancel because I only have 1 in the numerator. That really looks like about it. So now I bring everything over. 2 times x plus 1, denominator, x plus 4, x plus 4. Now, some people will tell you to go ahead and multiply all these back together again, but I like to keep it just like it is because I think it makes the domain restrictions easier, and it makes it obvious that we can't cancel anything else out. So that's going to be my final answer, and I'm going to say x cannot equal negative 4. Okay? Okay, so that's all I'm going to cover for right now. We're going to go through division. It's really simple, or it's not too hard, but we're going to use that as our warm-up next time and go over division as a class. So I want you to stop the video, and I want you to work on the homework now for just simplifying and multiplying. That is, let me show you guys. So 4-1 practice. I want you to just simplify these and multiply these. Okay, so and we will go over this more when we're all together on Tuesday. So enjoy, and I will see you guys then.